So today we start with Ivan Drucker,
Hi.
fully relocatable machine language routines. And here we go.
All right. Hello, KansasFest. So, here, let's get this. I never use Keynote. How do I actually start the slideshow? Does anybody know? Aha, thank you. Okay. Woo. All right. So, we don't have a ton of time for this particular topic, so I'm going to go pretty fast. And if you have no experience with assembly language programming, this will probably feel a little opaque. If you have medium experience with assembly language programming, some of it may be unfamiliar. And feel free, if you're like looking at some instruction that is not something that you use or see or know exactly what it does, and say, hey, what does that do? And I will attempt to answer it quickly. If you know your 6502 in and out, this will all make a sense. Okay, so the topic of this talk is what it says it is. I am Ivan. That is my website with some of my Apple II stuff. Importantly, there are numerous examples there because I have written many small programs that use the techniques that I'm going to be talking about. And the source code for all of those is available on my website, the assembler source. And the assembler source, because I use a janky JavaScript HTML-based assembler, is just plain text. So you can just open it on whatever computer. It's not like you need Merlin or something. In particular, there's going to be one utility called Pager, which is included with the NuInput distribution or NuInput source. Because I thought this session was at 9:30, I didn't quite get the commented version of Pager up online, which I only just did last night. So if you want to check out, I will upload that after the session. But if you were to download it right now, Pager is uncommented and therefore harder to follow. Okay, why relocatable? Well, first of all, what is it? Relocatable code is, rather than specifying an address like 2000 or 300 or whatever machine language address you want your code to run from, you can run it from anywhere. It does not care. And what are some of the reasons you'd want to do this? I'll tell you the reasons that I want to do it. First of all, I think it's neat, so that's always the first reason that I like to do an Apple II thing. But in particular, much of what I write are AppleSoft helper routines, and one of the problems with an AppleSoft helper routine is where do you stash it? Because if it's in memory somewhere, it can get overwritten by loading high res, it can get overwritten by variables, it can get overwritten by the program itself, and you can certainly, there's all kinds of techniques for creating protected memory things and then manipulating high mem and low mem, but all that stuff sucks. I'd rather, where I want to put it is between the end of the program and the start of the variable space, but that could be anywhere. So I want code that can run anywhere. So that's my particular use case. That makes sense to people, sorta? Cool. Okay. But whether or not that's just mine, but if you want some general purpose tools that can be run in with a variety of who knows what else is going on in the machine, it gives you a lot of flexibility if you are not fixed to one address with your program. How much time do I have left? I should set a timer so I can pace myself.
About 15, 20.
Okay. Thank you. Thanks, Doc. All right. All right. So how do you write relocatable code? The two methods that I'm basically aware of, although maybe there's others, are one is avoid any absolute addressing. So that means your standard like LDA 2000 or JMP 4000. Like, you can't do that because those are fixed addresses. And that's what I'm going to be talking about, is how to write code while avoiding that addressing mode. But you also have the option, and this is probably more suitable to something larger, although it's work and it's fragile, is to write whatever, address-dependent code you're going to write, but have it start within a init routine that is relocatable, that then goes ahead and modifies its own code to run wherever it is. And an example of that is the DOS 3.3 System Master was intended to run on 48K machines or 32K machines. And so when it boots, you'll note it'll actually boot a little slower than a slave. And the reason why that is because it is relocating itself for the address that it's going to run at. We're not going to talk about that at all today, but it's a valid method, and you can certainly do a hybrid of both. Okay. I target 6502 because my feeling is that if you're going to write for an obsolete platform, you want to be as inclusive as possible. But it so happens that 65C02 does have several useful new doodads that particularly help with the thing that we're going to do today. And I'll briefly address those at the end. And I don't know what's going on in a 16-bit world. It's not my jam. All right. So like I just said, these are the things you cannot do. You can do them if you're actually careful, but you would first need to set up relatively what addresses you're touching. You can't be dependent on a specific memory address to be available all the time. So this is what we're going to avoid doing. Okay, so how do we avoid doing that? We avoid doing that by using indirect addressing. So depending upon how familiar you are with machine language, you may or may not use indirect addressing, but basically the concept is that you, rather than going directly to an address, you look inside that address, which acts as a vector, and then you go to whatever is contained inside that address. So for example, if you have in location 0 page CECF, and you have the address 2000 in there, stored as 0002, and then you do an indirect address to CECF, it's going to take action at 2000. Does that make sense to everyone? Great. Okay. So these are the available indirect addressing modes. The most common one you're going to use is, I forget the order. I think it's either indexed indirect or it's indirect indexed. I can't remember which way it's called. But the point is, it's whatever the contents of 0 page is, and whatever value's in there. So like if it's 2000 plus y. So then if y is set to 9, it's going to take action on 2009. Also available, but less flexible, is 0 page comma x, but you'll notice the x is inside the parenthesis. That means that x is almost always going to have to be 0 unless you're being very clever with your 0 page. Because what happens is if you refer to C, unlike the y form, if you refer to CE, but you're doing it with this x way, and x contains 5, you're not going to get CE. You're going to get D3, I think. So unless you want what's in D3, you would normally have x be 0 if you're going to use that address form. There's the third one, which is indirect address. That's really, I think, only available on the 6502 with the jump instruction. You can go jump to an indirect address. In this context, it would probably be an indirect an address that's stored in a 0 page location, which is why I put the 00 in front. But there is no 0 page address form. There's only the 2-byte address form. It is also absolutely fair game to refer to something in or to jump to a routine in ROM, because ROM never changes. You can count on it. And in fact, one of the things that is helpful is a ROM listing. All right, so then if you have a 65C02, you do get a 0-page indirect address mode without having to muck around with Y or X. And you also get what is sometimes called a jump table mode, where you can refer to an address, a 2-byte address plus X. I don't really do 65C02, so I haven't thought through the use cases there, but I'm sure there are some. Okay, here are things you're going to want to know. You're going to want to know the stack and how it behaves in and out, and the S pointer, and how JSR and RTS, and if you like, even RTI, interact with it. You're going to want to know what all the 6502 flags do, including overflow. I'm happy to explain overflow if anybody's not clear on it. It's one of those sort of mystery flags. What the bit command does, also sometimes not well understood. You don't really have to worry about PHP, PL, PRTI, but they are available and potentially useful if you need. It is helpful to know what ADC and SBC do and how they affect the carry flag and the overflow flag, and the reason for those is because you might be using them to calculate a relative address to where you are. Want me to expand on anything that I've said so far? Okay. All the branching instructions and what they do, like BCC, BCS, BEQ, BNE, and the others. And then, and I have a separate slide on this, you're going to need to know what locations in 0-page are safe to use, because you're going to want a lot of 0-page at your disposal, because 0-page is the one safe area of memory that you can count on without having to relatively calculate for it. Okay. Here's what's helpful. If you have listings of the ROM, Apple has published those in their manual, in their like TUI reference manuals and that sort of thing. You can also, if you Google, you can find it online. AppleSoft source listings you can find online. Someone has disassembled and commented it, which is incredibly useful. Those are great because if you go like picking through that, you can actually find bits of code that do work for you. And that connects to the next point, which is I try to conserve as many. My stuff isn't very cycle dependent, but it is very byte efficient, and partially that's just as a matter of personal pride. But it has a real practical application, because most of your jumps are going to be via branches, and branches can only be 128 bytes away. So the fewer bytes you're able to run your code in, the less stress you'll have trying to get to where you're going to jump to. We will get to that. This is true of any assembly language programming, and having a stepping debugger, such as the one built into the Virtual 2 emulator for the Mac, helps. A sense of amusement and or patience is also helpful. I enjoy this a lot, but your mileage may vary. Okay, 0-page safe spots. So, as I said, you're going to need because you can't just go arbitrarily loading and saving bytes in memory. Really, your only consistent RAM that you're going to have like solid access to is 0-page. But 0-page is used by a lot of stuff in the system, so you need to know what's safe to claim as your own in 0-page. So if you want your stuff to be compatible with AppleSoft ProDOS and DOS 3.3, this is what's available. If you don't, now you'll notice this one says borrowed semi-safe. Those items are not formally free, but I've looked at what they do in the ROM, and I determined I can use them without impacting the system operation. There are probably others if you want to troll through the ROM. And furthermore, if you don't care about AppleSoft and or ProDOS and or DOS, then you can get many more safe spots, and there is a chart that exists, I provided a URL, that shows you exactly which of those things are using which 0-page locations. So if you're running something that has no need for AppleSoft, it can trample all over it, then feel free. It's like you then get 20 or 30 more 0-page locations at your disposal. I'm just in the interest of time, I might not jump into my code. Maybe I will at the end. But I'm putting it the example here if you want to see this in action and all of these safe spots used in something that is intended to be compatible with all of those environments. You could look at my NuInput source code. Yeah.
What do you think the idea of just grabbing and dumping to 6 bytes, do what you do, and then shuffle back?
If you can make it work, I think it's awesome. I mean, it seems like a good idea. Sure. If what you can do is grab everything, do your business, put it all back, that works for me. The challenge will be just where you're going to copy it to. But if you figure that out in a way, you could even reserve that space in your own program. You could just have those 250. You could have a page in your program just reserved for dumping in 0 page. It's a good idea. My stuff that wouldn't work with, because it's like I'm writing alternate input routines for AppleSoft, so things need to kind of run in the background. But yeah, sure. And I want certain things to be persistent in that cycle. So I'm going to be coming back to the monitors interact. It's like if I go to a get key or a key in, or whatever the API is called, that's going to be sitting there waiting, blinking, and I need to make that call, and it's going to mess up stuff in 0 page. But I'm going to need certain stuff in 0 page to remain the same regardless. But yeah, sure, you could do it. You could probably also get fancy with bank switching on the 2E, with the 128K. But anyway, there's plenty of possibilities. Okay, so branch, don't jump. You can jump indirectly, but it's a nuisance. The whole point is the places in your program that you're going to want to be going are usually relative to where you are. So jump, you can, if you calculate for it, but it is not as easy as just using a branch instruction, which is inherently relative. Branches jump 128 bytes in either direction. So, on a 65, so what you really want is a branch always. Now, the 65C02 miraculously has a branch always command called BRA, and that's just is a huge boon to this kind of coding. But I don't. But if you're coding for 6502, then you're going to want to do something like CLV plus BVC, or CLC plus BCC, or SCC plus BCS, which will effectively branch always. Whenever I do one of those in my code, I always comment it with a BRA off in the comment, so that I know that that's not your normal conditional evaluation. It's just a jump. Now, if you calculate for it and you want to use indirect addressing to do a jump, go to town. I don't do that much, but maybe I have somewhere. And then if you have a 65C02 and you're coding for it, use BRA, because that's great. And so if you want to see a simple example of this, and you want to look at one file, Pager, which is the one I have not yet finished uploading. It's there, but without comments. But I'll add the one with comments. Pager is the one you want to look at. It's a nice, simple program that just goes ahead and displays a text file on the screen. It's easy to understand. It's small, but it demonstrates many of the concepts involved in this, including using branching, not jumping. If we have time, we'll look at Pager. Okay. So sometimes where you're going to want to jump to, or branch always to, is just more than 128 bytes away, and that's how it is. So my technique for dealing with this is something that I call branch bridges. So you will just put in, an instruction somewhere that just, so if you've got, for example, a BVC to wherever it is that you're going, then there will be another line somewhere that gratuitously just has another BVC to where you're going, so that you can go hop, and then it's up to you for your code in between to hop over the bridge. So I kind of outline this in here. The Keynote format's not the best thing to read, but it's fine. It's the general principle. Does that make sense, what I just described, using a branch bridge? Okay. Because I like to be efficient, I also like to look around and see, do I already have one at my disposal? And sometimes I do. And in which case, I'll put in how much more do I have? 2. I showed 9:22. Do I not have till 9:30?
Well, let's say 9:30.
Okay.
Get that meant for switching.
Okay. So anyway, so I like to call those things mini bridges, and I will put in a label in my assembly source, you know, a little miniature bridge name above what is otherwise organically there as available without having to formally insert a bridge. Pager has those in it, so you can see it. Probably the most robust example of all of this is NuInput, but NuInput is big and complicated and hard to follow. But there are some like bridge things in NuInput, like a long loop, and that's just how I had to do it. Okay. One thing you're going to need to know is where you are. I'll go quickly through this, but basically there's a technique you can do it. There's a miraculous spot in ROM that gives you exactly what you need. You can JSR to it. It puts because it's a JSR, it puts where you are on the stack +2, and it returns the stack pointer in X. So as soon as you JSR to FF54, you then can immediately do a TXS, which puts the stack pointer back to where it was at the time of the JSR, and then you can pull them off the stack and do what you like with them. Any questions about that before I move on?
The TXS, it's not an exchange, it actually modifies the stack.
Sure, the stack pointer.
It's a pop.
It's not a pop. It doesn't modify the stack. It modifies the stack pointer, which adjusts the level of the stack. So when you come back, you're from the JSR, you're to above where you in the stack level where you want to be. The TXS puts you back to below where you want to be, so you can then pull the addresses you want off the stack with a PLA. Lammer has a good example of that at the beginning of it. Okay. You can use the same technique for relative subroutines, which is very exciting. I think this is the neatest thing here. So you can actually have a subroutine that is relatively addressed rather than having to JSR to a known address. So you do the same thing. You JSR FF54, does the thing that I just told you about. You then immediately do a BNE, which in that context acts as a BRA, or if you're 65CO2, you can just do a BRA. Then your routine, the first thing it does is it starts with a TXS, so now you have access to the return address that you're supposed to be going to, and then you do whatever you want in your subroutine. Then you need to do an LDA 00 or an LDX 00 or something that is going to set the zero flag that is going to set the zero flag so that when you return, you don't go back into the loop endlessly. So it falls through the BNE. If you're using BRA, you don't even need to do that. Alternately, you can in your routine, you can manipulate the stack pointers, and in Pager, there's one that does that. For one that follows the pattern that I have here, you can look at text file loader, which also comes with NuInput. Okay, we're almost at the end. So state keeping. Sometimes it's just good to have a bit or two, especially in this sort of resource-starved environment, that you can just keep a state with. So. The easiest way to do that is reserve a byte just for bits 6 and 7, because when you execute the bit command on that byte, you will get the result of bits 6 and 7, and you will then be able to branch accordingly from them. So in the interest of time, I won't go into all the details of that. If you're not 100% sure what bit does, check it out. But by doing that, and by setting those bits, and also as a means of setting those bits, using rotates and shifts can be very helpful. And I do this in Pager if you want to see how I'm doing it that way. And in particular, the overflow flag is really helpful one because almost nothing changes the overflow flag. So if you just need a simple bit toggle that is going to mostly stay undisturbed, overflow flag is a good one to use. And then alternately, if you want to reserve an area in code and calculate where that area is and then access it via conventional addressing, you can. Pager gives it some example of state keeping, but I use it in everything. The stack. The stack is a stack. If you know what the stack is, you know what it can be used for. You might want to manipulate the RTI behavior with it. And I'm not going to go into this, but do note that one way you can access the data that you may have stashed on the stack is by just going LDA 100, these are bonus instructions in 65C02. I think I've covered most of these as I've been talking. Some of these can be very helpful. There's my web page. It's got my Apple II stuff on it. And if you want to check out, in particular, Pager, once I upload it, I'd recommend that for seeing this technique in action. And but I apply these methods in all of these 5 things. Any quick questions? Okay then. Thank you all very much. Hope you enjoyed the talk. Hope you enjoyed KansasFest 2019. And thank you for coming and for your presentations.